Alright, so tonight we're going to be talking about rocks. And a fun fact for you, in case you're doing trivia or anything, petrology is the study of rocks, which is also known as geology, which is one of our four main branches of earth science. So we're getting into the fun stuff of earth science, which is kind of cool. Oh, and there is a rock with a goat. Well, that's a sheep on top of it. So, cool. Rocks are the record of our planet's past, which is kind of interesting. We can tell a lot about our Earth just based on rocks and what they look like. Rocks are where rivers used to flow. They are where huge inland seas were located, so we can kind of tell where seas were. We can tell what lived in those waters based on the rocks. They also tell stories of glaciers and how an ice age has changed our planet. They can also tell us about the climates in the past, which is also kind of cool. So how are rocks alike and different? We've got marble on one side and conglomerate on another, which are two very different rocks. I mean, completely different rocks. So look at both of those pictures and describe the two. Include the color and the texture. So marble, you might have said, is white. It's a little bit more smooth. Conglomerate's got this brownish color to it. It kind of looks like all these rocks are kind of cemented together into that rock, which is kind of cool. It might even look like throw up to you or your dog's throw up, which is really gross, but marble definitely doesn't look like that. Okay, so what is a rock? This is where you can start your study guide or your notes. A rock is a mixture of minerals and sometimes organic matter, like shells. Again, organic does not mean healthy. It does not mean healthy. It just means that it was once alive or it's still alive, okay? Example, if you look at granite, right here, 35% of it is quartz. 10% is mica, which is the dark spots. Feldspar is 55. And of course the ratio can vary a little bit, which gives us all these different colors of granite. So not everybody's granite countertops look the same. Rocks are definitely not elements or compounds. Those are minerals, okay? So make sure you know the difference between a mineral and a rock. A rock is a mixture of minerals. Alright, and again, this is kind of pointing out the different types of minerals that are within granite. Quartz is the shiny part of it, feldspar is usually the white part, and mica is usually the dark parts. What minerals make up other rocks? And again, you don't have to memorize this. Basalt has all those in there, marble has those in there, rock salt has halite in it, sandstone has quartz and feldspar, limestone is mostly calcite, and all those other things, okay? Now notice that all of them are all mixtures of minerals, okay? So make sure you know that. How geologists classify and identify rocks, and how you are going to be doing this as well, are three main things. The first one is texture. So this is different than identifying minerals. We're not going to be looking at streak plates. We're not going to be looking at luster. We're going to be looking at three main things, which are texture, composition, so what it's made up of, and origin, or where it came from. So three main things, very, very important, and that's how we classify and identify rocks. Texture, so if you look at the grains, are the grains large or small? Are they smooth? Are they pointy? Are they glassy? Are they smooth, chalky? Blah, 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 blah. So grain size is the first thing that we're going to look at when we're looking at texture. The first thing is it's coarse grained. So that means that you can see the mixture of those minerals without even looking at a microscope. So an example of this would be granite, because you can see all those mixtures of those minerals in there without using a microscope. Fine grained is when you can only see it with a microscope. Okay, and then number 3 is no crystals or grains, because it was formed too quickly, meaning it's smooth and shiny like obsidian, which we'll look at in a little bit. You can also look at the grain shape. Are they smooth and rounded like conglomerate, which we looked at a little bit earlier, or are they jagged like breccia? You can also look at the grain pattern. Is it making a wavy, swirling pattern? Does it have layers, or is it multicolored like gneiss, or does it have just a random pattern? Alright, so here you can look at the different types. So fine-grained, you can't really see the mixture of it. You could definitely see the mixture if you put this to a microscope. Coarse-grained looks like this, which is kind of like granite right here. Conglomerate has round grains, and breccia has jagged, so it kind of looks like knives or something like that. Non-banded, meaning it's just very random, and banded, meaning that it kind of looks like layers. The second thing that we use to classify and identify rocks is mineral composition, or what the rock is made of. Limestone is made of 95% calcite and 5% aragonite. Scientists look at very thin slice under microscopes and do the test that way. So a lot of these you can't actually tell the percentages just by looking at the actual rock. You can do an acid test and look for rocks that have calcite, because you know if you put in calcite it might fizz. You can also do a magnet test, and that'll tell you if it has iron or nickel or even magnetite in it, because it'll be attracted to that magnet. The third thing is the origin of the rock, or how and where the rock formed. So this is actually very important, because it's going to give us these three main groups of rocks that we're going to talk about. Igneous is the first type, and we'll go into this in a little bit more detail in a couple more days. But you have intrusive and extrusive igneous rocks, and it forms when molten material, which is magma and lava, cools and hardens. It can form at the surface or even underground of a volcano, and your examples of igneous rocks are granite, basalt, pumice, and obsidian. The second one is sedimentary, and we have clastic, chemical, and organic, which are the three types of sedimentary rocks. Again, we'll talk about that a little bit more later. They are usually formed underwater, and they have layers. So those are some key things to know about sedimentary rocks. The particles that are in sedimentary rocks are called sediments, imagine that, which are pieces of rock, mud, sand, shells, and dust. And they can be cemented or pressed together by pressure to make that actual rock. It takes millions of years for this to happen, which means that rocks are non-renewable, just like we learned a couple of weeks ago. Most rocks on Earth are actually sedimentary, and your examples of sedimentary rocks are sandstone, shale, and limestone. Now, these are the rocks that may contain fossils, okay? So that is also important to know. Igneous rocks and the other type of rock that we haven't talked about yet do not contain fossils. So sedimentary is the only one that would have like shells or bones or anything like that in it. The third one is called metamorphic rocks, and those two groups are foliated and non-foliated, and they are formed because of heat and pressure or chemical reactions deep underground. And you can go about 10 kilometers deep, and that's where they're going to start forming. It has to be about 100 to 800 degrees Celsius in order for this to happen. And your examples of metamorphic rocks are slate, schist, and marble. Okay, some questions for you just to make sure that you were listening. What type of rock forms the fastest? That would actually be extrusive igneous rocks, and those are the ones that cool really quickly on the outside of volcanoes. What is a rock? You should definitely know this, because I feel like I have been saying this for the past week so many times. It's a mixture of minerals and sometimes contains organic material. What forces on Earth cause rocks to form? Heat and pressure. What can rocks tell us about the Earth's past? Well, age, what lived there, the climate that we used to have, and forces that might have happened on Earth. And then list the three basic types of rocks. You should know this: igneous, metamorphic, and sedimentary. And then what is the study of rocks called? And there are two answers for this. petrology, which is a type of geology. There are a couple more questions for you. What kinds of rock form from material that settles on the ocean floor? That would be sedimentary rocks. Molten rock between Earth's surface is called magma. Which type of rock is most likely to form in layers? That would be sedimentary. How do scientists classify rocks? There are 3 answers to this. You need all 3. According to the way that they were formed, which is the origin, as well as their texture and their composition. Alright, so hopefully you got all of your notes taken down and you are ready for me to see them tomorrow. Make sure you look over this a couple of times because we are going to start talking about those different types of rocks and also the rock cycle. So make sure you know how rocks are classified and how we can identify them. Have a great evening.